Hello, am I audible? Can we start?
Yes, Rehan sir, you are audible, but madam's mic is mute. Please check.
Just a second.
Is it audible now? Is this
Yes,
audible
yes.
now? Am I audible
Yes,
now?
ma'am. Yes, ma'am. You are audible.
Okay.
Uh, okay. So,
So shall we start, or
uh,
is that
just, uh, just,
we are
just
waiting for others?
just 2 minutes, madam.
Sure,
I will give the
sure,
introduction, then we can start.
definitely.
Okay. So, good afternoon, everyone present here on the virtual dice. Uh, Today's resource person, Dr. Sonal Desai, our principal, Dr. Sanjay Bokade, Vice Principal, Dr. Sanjay Deshmukh, Head of Department, Dr. Rajesh Kale, teaching and non-teaching staff, and all our dear participants. I, Professor Rehan Siddiqui, welcome you all for the second session of AICT AQIS sponsored 1 week short-term training program on and recent trends in energy management and audit. Topic for this session is energy saving in motors and pumps. It's my privilege to introduce our today's resource person, Dr. Sonal Desai. She is a doctorate in mechanical engineering in cryogenics. She started as a teacher in 1995 and later started her own consultancy in energy and green building. She has significant experience in teaching subjects of thermal engineering like heat transfer, power plant engineering, heat exchanger design, energy audit, etc. She has authored many research papers and technical articles and several technical reports. She has also written a handbook on energy audit, which has been published by Tata McGraw-Hill Publications. She has been awarded with Young Women Professional, making grassroots impact by in the education sector by Ministry of Science. She is a certified green building consultant and a approved BW auditor. I welcome you, ma'am, and I request you to share your knowledge with us. Over to you, ma'am.
Thank you. Thank you, Professor Siddiqui. I'm just sharing my screen. Please check that it's visible to all or not. Is my screen visible to all?
Not yet, ma'am.
You have to allow me to
Just a
make
second.
my
Just a
screen.
second. Yes, yes. Just a second. Now you can share, ma'am.
Is it visible now?
No, ma'am. Not yet.
Kindly confirm the visibility.
Hello, ma'am. Your screen isn't visible.
Hello. Have you given me permission?
I have made you co. Just try again. Yes, madam. I have made you a co-host.
Is it visible now?
Yes, ma'am. Your screen is visible now. Yes, yes, ma'am. It's
If it
visible
is
now.
visible to everyone.
Okay. Thank you.
Okay, okay. And I trust internet and audio both are
Yes, you're. Yes, yes.
receivable.
You are clearly audible.
Okay.
Okay, fine, ma'am. You can start.
So I'll start with my presentation. First of all, I would like to thank Professor Dr. Kale and Priyanka Madam for allowing me to present on this very relevant topic, that is energy saving in pump and motor. I also thank Mr. Siddiqui for allowing all these facilities to us. As already introduced to the audience of this well-known Sttp on recent trends in energy management and audit, which is hosted by Rajiv Gandhi Institute of Technology. I was working as head of mechanical department and professor in mechanical engineering. I have worked as an academician for almost 23 years, and later I have started my own consultancy in the field of energy and green building, because that are my subjects of choice. And I had also in parallel started my e-learning platform. So from some such similar platform, I got reference of Professor Kale, and he invited me for this course. And because of that, we are meeting on this wonderful platform today. I'm going to share some knowledge about energy saving in pump and motor. I have selected this topic and combined this in with the very reason that whenever there is a pump, most of the time there is a motor behind it. So I have clubbed in these two topics together. Ideally speaking, pump itself is a very detailed topic, and so as is the case with motor. But as they go hand in hand, I have clubbed these two topics together so that both energy saving potential which are there in both this can be highlighted. Again, I am from thermal engineering background, so please bear me if I'm missing some electrical fundamentals. I'll try based on my experience to cover those also, but if some electrical things are missed out in my presentation, kindly bear. I'm already been introduced, so I will directly start with my content of the presentation. In my first part, I'll be talking of how to have energy saving achieved in pump. And then in second part, I will be talking about energy saving in motor. Again, first part will start with basics of the pump, and then we will go with the details energy saving. And then similarly for second part, we will have how energy saving as well as energy efficient motors, how they are relevant to the today's scenario, and what energy saving potential lies in both of them. I trust that I'm audible to all and the slides are visible. If any discrepancy, if any internet breaking is there in between, please let me know, because this e-platforms are always a one-way platform where I cannot see your faces, I cannot listen to your comments. So if you will convey all your difficulties in a timely manner, it will help me to rectify them and then go ahead with them in a better way. So we are talking about this energy saving in pump because we know that world total energy, if we count, that almost 20% goes to the pump. Again, if we are talking of a manufacturing industry, which is related to some process or manufacturing process, this power consumption rate goes as high as 45%. So which is a very high, and we can say that next to HVAC, that is heating, ventilation, and conditioning, pump and motor are the candidates needs to be targeted so that energy saving can be achieved. Also, these are matter of concern because when we compare initial cost and running cost or a life cycle cost, then initial cost of the pump is very, very less compared to the life cycle cost. So it is always better that select the initially we should select the systems in such a way that the running cost will be optimized and overall life cycle cost will be reduced. So when I'll be talking about energy saving potentials, we will be discussing impeller trimming, how to retrofit pumps, what are the correct diameter piping so that it can reduce the burden on pumping load, and how to optimize operation hours. As I just said that energy cost is a major function when we talk about pump operation. So this is indication of energy cost. While this is the initial cost. You can see that it is very less. Again, it depends on the capacity, that is rating of the pump, but still for almost all cases, operation cost is very, very less compared to the initial cost. Hence, we should not target this much, but we should target this, because this is what we are going to pay in a long run, and all payback issues are related with this. In short, if you look where pump is used, knowingly or unknowingly, it is used in almost all industrial applications, and some of the application of domestics also. It is always used for pumping of water. Then whenever there is HVAC or a power plant, then it is used for a cooling tower water supply. It is used for boiler chemical processes to supply makeup water. Wherever there is a HVAC system, there is a chill water pumped, cool water produced by evaporator. So that will be again pumped. Used in a condenser also to pump the hot and cold water. Heating system is used, whichever is based on hot water circulation or steam based. There again it is used. And wastewater treatment also requires pump. So almost all engineering applications as well as major domestic application calls for one or other type of pump. The differences in industry, there can be reciprocating or some specific pumps are used. But in case of domestic, majority application deals with a centrifugal pump. So my today's talk is limited for centrifugal pump energy saving. If we wish, we can have in future about how to have energy saving in a particular specific type of applications too. We know that when we call a pump, the back of mind concept comes is whenever we lift a fluid, we call a pump, require a pump, or whenever we circulate the fluid, we require a pump. So pump is a device which has to meet two basic criteria. One is pumping and another is circulation. It might be a case that one is absent and one is present. Say for example, when there is a heat exchanger, we don't require head over there. Same water will be circulated at the same height or the same level. And when we talk about pumping of a water from ground level to higher level, over there, the requirement is just the head and just to meet the frictional losses. So a classification of pump goes like this. A major classification group is positive displacement and hydrodynamic pumps. Again, positive displacement has further categories like reciprocating, rotary, and all, while hydrodynamic have a centrifugal mix or axial type of categories. Centrifugal pump, it will be having something similar look as shown in the middle of this slide. There is a central portion which is called impeller. It can be open impeller or a closed impeller, which basically guides water to pass over it, and the kinetic energy which is received by impeller from the water, that is given to the water, and that kinetic energy is ultimately converted to the flow of the water. We normally select centrifugal pump for almost all applications because it's simple. It has got a minimum working components. It requires less maintenance, longer or life and durable, as well as wear and tear issues are less. So looking at all these feasibilities, normally centrifugal pump is selected, though its efficiency is not very high, but it is good to use. And they are further classified based on such types, like based on capacities, based on efficiency, based on head handle, input power given, speed at which it is running, or type of impeller, they can be further classified. So some diagrams and animations are there which are explaining these pumps. We will just go through it so that how to save energy in them can be realized in a better way. As just mentioned, the center portion, which is housed in this involute casing, is called impeller. That is receiving fluid, and fluid is getting energy of this impeller, and then at a higher energy, it is getting discharged. This centrifugal pump, okay, let us see some animations. So here it is how the function of centrifugal pump takes place. That's it's a motor which connects with this hub of this centrifugal pump and pumping takes place. So classification is, if we are talking on based on volute, it can be like this: volute casing, vortex casing, or diffuser ring type of casing. If we talk based on type of impeller, it can be open impeller where the fluid can be handled, which can be abrasive in nature, or it can have some suspended particles. Then it can be used using open impeller, semi-open or a semi-impeller, or enclosed impeller. They are being used. Then staging can classify based on that, like a single stage. Here two pumps are shown in parallel to each other. Both are having suction created and delivery. They are mixing and then final flow is going ahead. So that is a single stage arrangement. While in case of a multi-stage, outlet of one goes to the next and so on and on. So wherever a higher requirement is there, it can be multi-stage arrangement. Pressurizing and squeezing of fluid takes place in this positive displacement pump. It's not like centrifugal pump. It operates on a pulsating manner. So it may create flow-induced vibration, cyclic loading. They are self-priming and they can be located. The advantage of positive displacement is they need not to be submerged always. And they can also handle viscous fluid. So for a particular industrial application, these are being suggested. So these are animations for positive displacement pump. Few are for piston one, then there is for plunger one. So where there is a plunger which creates pressurization, then there is a gear pump followed by van pump, and there is a screw type of pump. So these are all examples of a positive displacement pump, but today we are talking about centrifugal pump in details. When we talk of a pump, a very important aspect is pump affinity laws, because they ultimately decides governing of the pump. So when we draw the diagram of a pressure versus flow or a head versus flow, it is called pump affinity law. And how they are important, that we will see in the subsequent slides. This pump versus flow curves, they are also called as QH curves or a pump curve, and they are right now they are shown for centrifugal pumps only, applicable for centrifugal pump only. While the system curve, which is again followed by a pump, that is pressure versus flow, that is shown over here. This system curve that shows two types of head. One is static head, that is how much head or a height fluid is been lifted, and then a dynamic head, that is what friction is taken care by a pump. So when we have overlapping created for a pump curve and system curve, it will be like this. And their intersection point that depicts operating point, advisable operating point, or a best operating point. It is good to operate the pump at this particular range. We will talk on those slides later. First, let us have a look of what is head. Head is basically a amount of head that is created by pump, that is a difference of height between supply and the delivery when we talk of static head. And when we talk of a dynamic head, it is how much friction pump is able to handle, that is dynamic head. Higher is the head, more is going to be the pumping cost, and dynamic head is proportional to the square of the flow rate. And total head is basically static head plus dynamic head. To calculate static head, we need to have data of pressure, that is at inlet and outlet of the pump. By knowing those data, we can calculate what is difference in the head. And to know the dynamic head, we can calculate it knowing the velocity and the density of the fluid. Once we know the density and then we know the diameter of the pipe, we can also calculate dynamic head of the pump. Hydraulic power of the pump is given by rho g q and we know that these are very fundamental equations. So as I was talking about, when we talk from energy performance, we should make our pump to operate at the best efficiency point. And that is where there will be a minimum power consumption and it will have a maximum efficiency achieved. So when we are operating the pump in and around BEP, it will have a minimum power consumption. But it is not always possible because the flow is continuously varying and at times requirement is also continuously varying. It all depends on end-to-end application. One example, if I give, say for example, we are running a pump for a cooling tower requirement. So cooling tower which requires water, which pumps water, that water level will not be same during all the weathers or during daytime as well as during night time. We know that it is based on the temperature of the surrounding air. So when surrounding temperature drops, the flow rate of water will also drop. So over there, the flow rate variation will occur. And in that case, we cannot make to operate pump to operate at a continuous flow rate. So whenever such requirement is there, and at that time, if we shift the pump operation point, it will hamper the efficiency of the point. We will have more slides to understand this, and we will be talking a lot about how to save energy by operating pump on a best efficiency point. So let me clear the fundamentals first, and then I'll come back to the point they are related with the operation of the pump. One more word which is always coined, that is NPSH, net positive suction head, and that is ultimately creating cavitation in the pump. Cavitation is a phenomena when the liquid gets vaporized and that is forming vapor bubbles. It is called cavitation. So that normally happens when the liquid pressure drops below the vapor pressure. So it should not occur, otherwise those vapor formation is always harmful because the pump is not meant to handle the vapor. This vapor bubble will create a blanket of the vapor that will damage the impeller, it will create undue noise, it will create erosion, it will damage pipe surfaces, and vibration will also create it. By and large, it will damage pump working, it will damage bearing, we have to frequently change the bearing, and this may happen if the pressure required is not maintained. So this cavitation can be avoided if we are maintaining NPSH, and it is recommended that plus 0.5 meter of NPSH is always to be maintained compared to the required pressure. Here are some more methods to decrease cavitation. We can reduce the pump placing so that the pressure will be changed and cavitation will not occur. We can increase system pressure in case of closed system. We can reduce the length and increase the diameter of the suction line. As length is decreased and diameter is increased, again, it will affect the pressure and the suction pressure will be lifted. Lowering fluid temperature, because if we are handling high temperature fluid or viscous fluid, then again, this is going to occur in the pump. So coming back to the affinity laws, they are basically for either for a fixed diameter or for fixed speed. So affinity law, when we talk about pump, they are flow is related to speed in a direct way. When we talk of a head, it is proportional to the speed square. And when we talk of a power consumption, it is in the proportion of the speed Q. So whenever we are talking of pump performance, we have to see that what is a speed. If speed increases, flow will decrease, head will decrease. If speed decreases, this parameter will decrease. But the decrement will not be in a direct proportion. They will be in a proportion to the square for head, and power is in proportion to the power 3 when we talk of speed is reduced. So let us have further look of affinity law for a constant speed and diameter varying. When we change the diameter, then again the flow will decrease. It is in direct proportion. Head will decrease in the power 2, and power will decrease in the power 3. So if we reduce the diameter, there is a less change in head, but there is a subsequent change in a power. So when we talk of making pump more efficient, foremost method is to change the diameter. If we reduce the diameter, initial flow will be varied by little, but it will have a huge significant effect on the power consumption. We will see them with the help of example also. So let us say that there is a centrifugal pump which is having a VFD. Let us talk of speed variation first. So this VFD based pump, which is running initially at 3500 RPM, and it is delivering 1100 liter per minute of the flow and is giving 88 meter of height. For that, power consumption is 26.5 kilowatt. These are initial running condition. If we reduce the speed by 2900 RPM, then what is the change that is going to occur in the performance of the pump? That is shown over here. By reducing the speed from 3500 to 2900, we can see that the flow will be reduced. Initial flow was 1100 liter per minute, which is getting reduced to 911. Same way, head, which was 88, due to reduction in the speed, it reduces to 60 meter. And power, which was 26.5 kilowatt, now it has dropped to 15.07 kilowatt. So if it is okay to have lesser head, then we can adopt this variable frequency drive, because we can see that reducing speed, pump delivers less flow and lower head. But at the same time, power consumption, which is 15 compared to 26, it is 45% lower. Hence, we are directly reducing power consumption by 50%. So if the oversized pump was selected, or a load variation is there due to, as just mentioned, cooling tower is there, or a day-night variation is there, then go for VFDs. Also, if you are continuously running a pump for more than 4,000 hours per year, and we are varying the load by 20 to 30%, a thumb rule says that use of VFD is always good, because it will have a payback of less than 1 year. So on a system curve and a head curve, it is shown initial speed. When it is higher, we are operating at this point. When we are reducing this, it is operating at this point, and further reduction, we are making it operate at a further lower point. So it will reduce head as well as flow, but at the same time, at the same efficiency, we will have reduced power consumption. So this is one of the method to reduce power consumption in the pump. Next, we are going for how to understand the effect of impeller diameter. In this case, impeller centrifugal pump is given, wherein there is initial is 11 inch diameter, which is reduced to 9 inch. Impeller, by this time, I believe you understand that a center portion that imparts velocity to the fluid, and it is a main part of the pump. So initial diameter is 11 inch, which is changed to 9 inch, and its effect is, if we change from 11 inch, what is the effect on the power consumption as well as heat deliver and flow, that we have to look forward. Initially, it was 11 inch, changed to 9 inch. Initial flow was 1135 liter per minute, as it is mentioned. So we can see that flow is reduced from this to 928 liter per minute. Likewise, head is reduced from 34 meter to 22.76 meter. And the power consumption is, you can see that it has reduced to almost half, 5.75 compared to 10.5. So friends, what is cost involved in impeller trimming? It's just nothing. With a few $100 of trimming cost, we can save energy in the impeller. We can save energy in the pump by trimming the impeller. Next, we are going to look at what are the effects of flow control on the pump. We know that the pump which is designed, most of the time it is oversized pump. Our Indian mentality or Indian thinking is just like that. We always think for tomorrow. We will think for the application which is not we are using today. Say by chance we will be having one floor added to our building, we will be having one more heat exchanger added to the plant, or we will be thinking of few more persons who will be occupying the home. And based on those assumptions, we make that assumption that our future requirement is larger than today's requirement. So my present requirement is 1.5 HP, I'll go for the 2 HP pump, or if it is 2 HP, then I'll go with the 3 HP pump. So it is something like that. I'm driving my car, I'm putting accelerator as well as brake together, and then ultimately I'm complaining about and my car is not getting full average. So just like that, same thing happens in pump. Most of the cases, looking at the future need or looking at the variation in the load, we design the pump in such a way that we, based on compared on to the present requirement, we go with the higher sizing. And ultimately, we need to control the flow because our present requirement is less and our present equipment are not able to handle more flow. So ultimately, we have to control the flow. That is basically controlled by different devices, and it will create either mechanical loss or hydraulic losses. So types of controllers and their effect on the pump working system, that is talked in the subsequent slides. Normally, throttle valve is used, which is most inefficient method. Then some cases flow bypass method is used, wherein rather than routing the flow in a required piping, flow is diverted to some bypass line and then it will go back. Later options are somewhat viable, but first two options are ultimately we are putting our leg on the edge and we are reducing the performance by increasing running cost. So why throttling is very inefficient, that is shown in the slide of again pressure versus flow diagram. When we operate the pump at this point, our useful energy is this. But when we make it throttle, what we are doing is we will reduce the flow from this point to this point. So again, initial flow, it was this. Now my reduced flow is this, but it has created undue head. If I have got a two-story building and if I'm pumping the head, which is pumping for 40-meter height rather than 20 meters, so those 20 meter I'm not utilizing. My overhead tank is at just on the second floor only. So why should I pump the water which is capable to reach till four-story building? So this is what happens when I select the pump of a larger size and then control with the help of flow. I'm wasting this much of energy. To understand the same, one more example is over here. Let us say that pump is operating initially at condition A. This condition A gives me the flow rate of 500 meter cube per hour and it is delivering me a head of 50 meter. At this point, pump efficiency is 82%. This is a good efficiency because here my system curve and these are matching over here and it is almost near to my best efficiency point. Now when I put a throttle in the pump, what I'll do is I'll make the pump to operate at point B. So over point B, my flow will be reduced from 500 meter to 300 meter cube per hour and my head will increase from 50 to 70 meter. As I just said, I'm not going to utilize this head, but my flow requirement is matched. So what I'll see that as my end requirement is matched, I should operate over that. But when I operate the pump at point B, pump efficiency is 77%. So 5% loss, and if you calculate equivalent shaft power and then electricity, it will be a huge loss. So rather than making it operate at point B, what is recommended? Have the pump operated at point C, which is again on the same system curve. It will give me a lesser flow rate, but this will be having lesser heat. So if 42 meter is okay with the application, I can have this achieved by trimming the impeller or reducing the speed. But again, it should be okay to match this gap, or else it is advisable that forget pump A, go for the new pump. That is even cheaper to run the pump in a long run. We will see the case study for this to understand this. these are the normal observations which are there and likely reasons and what we should do to have energy efficiency observed. If there is a case of throttle valve used, it is most of the time oversized pump. So if possible, trim the impeller, use the smaller impeller. It's not always required to trim the impeller. You can have two sets of impeller. Whenever you buy a pump from a manufacturer, same supplier, same OEM can also supply you another impeller which is of a lesser diameter. So you can keep the original impeller aside and then go with the smaller impeller, and you can use it to reduce the pump operating cost. Same way, go with the VFD or a variable speed drive. That will also reduce the speed. Also, you can opt with the 2-speed drive, high speed when required for more flow rate, or a low speed when you are running for a low speed, or reduce the RPM. So by any possible way, you can increase the efficiency and eradicate this throttle control system. Second kind of arrangement is when there is a bypass line used. As just said that flow is diverted from the main line. So same remedy is applicable as just applicable in a first case. If you find that multiple parallel pumps are there with the same number of pumps are always operating, then it signifies that pump use is not monitored. Use the control, it can be on-off control, it can be sequencing control, and according to the requirement, operate them. Same way, when there is a constant pump operation, then again, you need to monitor those things. If the pump is frequently failing in terms of seals or bearing, then again, it is indication. Also, if there is a vibration, then again, it is indication that pump is not operating its best performance. It is operating very far away, and we can match by redesigning their operating conditions. So this is very important slide for those who are looking for remedy in the existing pump. If you talk of numerical or a case study that how this flow throttling is affecting, then we can see from this diagram that here a case is given where we need a pump to handle 68 cubic meter per hour and we required 47 meter of height. So we can select pump A, B, C, D or E out of all available options. So out of all available options, if we go with a pump E, its operating curve is this, and it will have best operating efficiency over here. If we select pump A, then it will operate at 50%. Again, it will give us 68 cubic meter of flow, but it will give us a more head. And hence it is giving a more head, it is giving us a operating at a lower efficiency. So if we summarize the selection of pump E, then pump E will be consuming 8.7 kilowatt hydraulic power. If you consider 60% efficiency, it will have power drawn of 14.5 kilowatt. And if you consider the electrical motor efficiency 90%, then it will have 16.1 kilowatt power consumption. So my selection E will result in 16.1 kilowatt. While if I select pump A, it will have 50% efficiency. So it will draw 28 kilowatt, having a larger size. And ultimately, it will drop, considering motor efficiency, 31 kilowatt. So choice is yours. When we have pump E selected, its consumption, and when we have pump A selected, then its consumption. So the comparison shows that when we have pump A selected, it will draw 31, while when we select pump E, it will draw just 16 kilowatt. We are saving 14.9 kilowatt. Per year, we are saving 1,30,000 units. Yes, 1,30,000. So if you just multiply, this is the minimum power, minimum utility rate is taken. If you could consider 7 rupees, then it will be even larger than this. 7 to 8 lakh of rupees we are spending on selection of higher side. So initially we have invested more. That is first mistake. Then we are continuously investing more by running with the higher electricity. That is second mistake. So whenever there is oversizing pump, if you don't throw that pump, just disconnect it, go with the new pump, then again it will have payback achieved and your selection will be proved vice versa. Another arrangement to save energy is go with the series or parallel connections rather than going one large pump. It is always better. So when you are looking for a more head, arrange them in a series way, or when you are looking for a more flow, arrange them in a parallel connection. So this will also have a function of standby mode. You need not to run them all whenever you don't need to have a fullest capacity. So buying a small pump, putting them in a series of parallel way, that is also energy efficient alternative. If we talk about selection of pump, then multiple parameters are there. The important ones are listed over here. What are the properties of fluid, what pressure it is required, what is the flow rate required, at what temperature it will be handling, then initial cost is concerned or not, maintenance cost, is it very important, and then pumping layout. So whether we are buying a new one or where we are retrofitting, we have to consider certain criteria. So this is in general diagram which is showing that in which case one should go with a centrifugal pump. When there is a low head, high flow requirement and a less viscous fluid is there, go with the centrifugal one. If high head is required, the low flow rate and the fluid is viscous one, go with the positive displacement one. It can be piston pump or a band pump. Other important parameters which are deciding selection of pump are whether the fluid handle is acidic or basic in the nature. If the pump is operating above 100 degrees centigrade, then we should consider the expansion of the bearing, seals and other parts. Whether the fluid has got abrasive particles, then again we have to select the impeller and internal construction accordingly. What are the thermodynamic properties of fluid? If apart from water is used, what quality is there that we have to consider. Again, this one more slide is there which shows how to have optimizing of the pump for energy efficiency point of view. That is, oversized pump is there, then go with the multiple pump, change the impeller, select a smaller pump so that it operates near efficiency point, go with the variable speed drive. Whether if there is a flow throttle, same applications are there. If there is a wear and tear, then go for regular maintenance. Oversizing is there, oversized motor is there, go with a smaller one. Inefficient motor is there, then go with the E1, E2 motor, or insufficient pipe diameter is there, then enlarge the pipe diameters. So correct sizing of pump plays a very important role. Don't look for the present need, accordingly decide the pump. When you come to know that pump is oversized, when there is a flow noise, when there is a throttle, when there is a bypass, when there is a frequent failure of bearings. So these are all indications of oversizing and they are resulting in a higher head or a continuously throttling of flow is required. So replace of impeller or speed drive or a smaller pump, they are the remedies. Here the effect of trimming impeller is shown that in this diagram, when we have trimmed the impeller, we are making it operate over here. Initial operating condition is this, and after trimming, it is this. So the thumb rule says that up to 25% of original diameter can be trimmed. So if a 10-inch diameter impeller is there, we can make it up to 7.5 inch. And if 10% or more flow is continuously throttled, it is advisable to trim the impeller. So one more case study is given for trimming of the impeller. A centrifugal pump which has 14-inch initial impeller diameter. It was delivering 12,000 liter per hour of flow rate and it was operating at 8200 hours per year and it was delivering 50 meter of head at 82% efficiency, consuming 120 kilowatt. For this operation, is it's required that now we need 37-meter height at the same flow rate. So we don't need to change the flow rate, but we need to reduce the height. And is it advisable to trim the impeller? If yes, then what is the diameter it should be trimmed off? So initially it was 14, and now with the requirement of 37-meter height, the new diameter is 12 inch. With the change in the diameter, you can see that 120 is directly slashed down to 75 kilowatt. So if you talk of energy saving per year, it turns around 23 lakhs of rupees. So it's a huge amount. Hence, that impeller cost is just nothing. Over here, it is assumed that pump and motor efficiency remains unchanged when we trim the impeller. Ideally speaking, they will also change. And the performance curve followed over here are this. Some more energy saving potential is there is always keep working clean condition and maintain it routinely. So that will help to reduce cavitation. If there is a cavitation, there will be increased clearance between fixed and moving part. There will be wear and tear. Then select the right size motor. Many a time this is neglected. Pump is properly sized, but the motor is oversized. So that inefficiency will also added in the pump working cost. Review the flow methods we have already discussed. So I'm skipping this portion. Go with a variable speed drive. It is a energy efficient flow control method. It is used whenever 2000 hour or more pump is operated, or a 30% or more flow variation is there. You are supposed to remember this to implement it whenever you come across such opportunities. So either mechanically or electronically speed will be reduced, and they are always having a good payback. So go for it. Speed variation in mechanical one can be based on clutch, belt or pulley, or in case of electrical one, it can be based on eddy current or a water type of arrangement. Go for a multiple speed pump. High speed, low speed pump is there. A very good example of that flow chart is given. When you're operating it, it's high speed, its performance point is this. On a same performance system curve, when you're operating at a lower speed, it is at this point, and at a lowest speed, it is this point. So rather than trimming the, controlling the flow, which will shift these points on this side, and it will make head increased and ultimately power consumption increased. It's always good to reduce speed of the pump. Check the pipe layout. It should not be too big. It will create pressure loss. It should not be too small. Otherwise, it will create frictional loss. There should not be undue unnecessary sharp bends, expansions, and contractions. So that will also create friction. Select a low loss wall and pipe fittings. Don't go with the globe walls. It is also bad to have more flow losses. So to summarize the pump part of energy saving, we have to identify the requirement based on this pumping requirement. It should be, pipeline should be well insulated, because most of the time we handle either chilled water or hot water, or sometimes steam is passed on. So it should have proper insulation. It should also have water efficient process and equipment. Not only pump, they are also playing a vital role in overall plant energy saving. Minimize need of compressed air and chilled water. If you reduce requirement of HVAC chilled water, ultimately pumping load will also reduce. Minimize distance and height, because that is also good to achieve, because if the lower distance is there, then also pumping power will reduce. When we are designing a pumping system, consider a present pricing to select the motor. If your pumping system is older than 15 years, you have to blindly replace it, because 15 years back, the energy cost was something different. At that time, pump cost was a priority. Today, running cost is a priority. So if you are into engineering field, engineering industry, and then if you are having pump which is older than 15, 20 years, rather than running that old machine, you should replace this. always remember that old is not gold when we talk of energy efficiency. Old is always consuming more in case of energy efficiency field. Normally, oversizing is done to meet the future requirement. Don't do it. Don't consider scale buildup. Rather than go with the cleaning of the pipeline, maintaining it so that cleaning will be there. That should not be throttling. Select a variable speed drive or a multi-speed pump, and always not go for an oversized pump for a safety margin. You don't need a safety margin in a pump. Pump is something which you can always add on, because whenever a pumping system is there, there is always a flexibility to add extra pump in future. Adding few feet of pipes and one more pump is always less costlier effort than running a big size pump continuously at a higher rate. And some more in the list. Select efficient pumping components between pump and the source. Use less bands, use shallow bands, use right pipe material which is less friction. Plastic and glides has minimum flow resistance. Steels are even smoother compared to galvanized one. So these are the thumb rules to remember. And to summarize the first part of my presentation, that is pumping energy saving. If 10% or more flow is continuously throttled, trim the impeller. Your pump should always operate in and around 20% of the best efficiency point. Remember, we cannot make it always operate at the same point. Again, voltage induced variation will always be there. So 10% here and there is always okay. Normally, NPSH of 0.5 meter is recommended to avoid cavitation. Use up to 25% of original diameter can be trimmed for impeller. And variable speed drives are always advisable when there is 2000 hours of annual operation, or there is a 30% of flow variation is there. So this was all about energy saving in pump. And now going to the next topic, that is energy saving in motor. I'll just have a sip of water, please. So friends, in the second part, I'll be talking about energy saving in motor. Motor is always a backbone of a pump, not only pump, to many other devices. Whenever there is a fan, whenever there is a compressor, whenever there is any driven rotary machine, there is a motor used. And the problem with the motor is we normally don't buy motor from the industry. We either buy pump, we buy compressor, we buy fan. So what is a motor type? Whether it is energy efficient motor, what are the performance parameters of motor, that is not been asked. So this energy saving in motor is very much important, because there is a huge power consumption in the motor. This is the one which is used universally, largest used rotational device we can say in the world, that is motor. And it is highly ignorant. People don't consider energy efficient motor usage while buying a motor. Manufacture again, and some more issues with the motor is there are multiple standard exist. Even in a single country, there exist 3 to 4 standards which motor has to follow. So a non-technical person will always get confused that which standard one needs to follow. Manufacturers are using words like super efficient, energy efficient, hyper high efficient. So those are also misleading. And hence there are multiple myths when we talk about energy efficiency of motor. And one need to consider these facts before deciding type of motor to be used. As just said, the major component of electrical energy in industry is consumed, that is electrical motor. Energy efficient motor which are available now, they are 2 to 6% more efficient compared to standard motor which are used in practice. Efficiency improvement translates into substantial energy and money saving. Whenever we save energy, we are not only saving money or a running cost. By and large, we are saving environment. By and large, we are saving our nation's energy consumption. A motor-driven system which consists of several components, like not only motor is important, there is a power supply, control, transmission. So we have to optimize all. Just optimizing pump and motor will not have system efficiency achieved. We should also think of power supply and many other parameters. Just a second, please. Sorry. This slide shows the costing, use of motor, where the motor is used. A reason for deciding this motor to be clubbed with the pump is this: 42% of motor which are manufactured in India, they are used in pump. Then other usage of motor is to run the fan, to run the compressor, HVAC or RAC compressors and all, condenser, evaporator, motor, etc. And remaining other industrial use for transportation or operating devices like that. So major application of the motor is there in the pump, compressor and pump, fan, we can say. If we talk about internal of the motor, it is like this. Motor is having internal components. There is a red rotor, stator, bearings on the end, fan for keeping it cool, insulation, and then some other accessories. What is important in motor is it is loaded at an appropriate rate or not. So whenever a motor operating below 40% load, its efficiency will be less. So it is must that motor should always be loaded at least at 40% load. So how to check motor loading? From electrical fundamentals, there are three methods to identify loading of the motor. One method is direct electrical measurement. Another method is a sleep measurement, that is change in speed. And third is nameplate or amperage reading that can also confirm the loading of the motor. So I'm not going into the details of how to confirm loading of the motor. By these three methods, loading of the motor can be calculated. And by knowing this loading of the motor, we can identify that whether the motor is perfectly loaded or not. For all these three methods to calculate loading, examples are given. So those who want to refer that can refer this PPTs on a later run. So going for energy saving potential in motor, first and foremost is selection of right motor. Just like pump, it is important that motor should have a right choice made. Then only we will be making it operate at a right efficiency. Many times an oversized motor is selected to meet future requirement. As just mentioned, just like pump or any other engineering application, make it run at an oversized condition, we are reducing efficiency as well as we are reducing power factor. By reducing efficiency, we are paying more electricity. By reducing power factor, we are paying penalty related to the power factor. So that will have higher installation cost, higher running cost, and increased operation cost. As stated earlier, motor reduces power factor, and that will create magnetic field, which will create phase difference between peak voltage and peak current, and it will also create reactive power. So this reactive power ultimately creates I²R losses, stress on transformer, and for that, the utility company maybe Maharashtra Electricity Board or any other board, they will make a penalty to the end user. So large motor users should always install capacitors to correct the power factor. That will have a dual benefit, that the penalty will not be laid to them, as well as the other equipment used in-house or used in the other nearby connection, that will also safeguard. So selection of right motor is, first thing is, when an undersized motor is used, it will operate in an overload condition. So it will have its effect on the life of the motor, its winding will be affected, and it will have a higher temperature operation. And when there is a demand fluctuation predictable, always go with the 2-speed motor. As just given a case of a cooling tower, during night time and daytime, different flow rate is required. So over there, don't run the single motor. Use twin motor or use the 2-speed motor. So over there, it will have power optimized. For a similar weather dependent application, use of 2-speed motor will save the energy. Go with the 3-phase motor. 3-phase motor will have a better power factor compared to single-phase motor, and it will also have a higher efficiency. So wherever permissible, go with the 3-phase motor. The rating of motor increases with the number of phases. It is a basic fundamental. Rewinding is a very common phenomenon which occurs in electrical industry and in particular in our country, because we people have a mindset is to repair the things rather than replace it. So whenever we repair a thing, and if we do it non-technically in a layman's way, we are ultimately making higher and higher energy costs to be paid by the company. So guidelines for rewinding are there in this consecutive slides. If there is an older U-frame motor which has oversized slot, it will have reduction in I2R losses. Add more copper to that, so that will reduce those losses. And if the original motor was bound with aluminum, then replace it with the copper. If it is necessary that we have to rewind the motor, then go with the higher size wire rather than reducing the size of the wire. Then reduced number of winding will also have reduced winding resistance. So motor's peak efficiency is directly related with the windings resistance. And to remove the older wiring, normally labor person will heat up the motor to remove the insulation, but make sure that in any case that temperature does not increase 350 degrees centigrade, otherwise it will damage the motor. So make it operate at lower than 350 degrees centigrade. Then whenever we are doing rewinding process, always measure the resistance after each and every rewinding. If the motor is 15-year-old and less than 100 HP size, it is always good to replace the rewinding rather than always good to replace the motor rather than rewinding it. If the rewinding cost is more than 65% of the purchase cost, right? If your motor cost is 1 lakh rupees and rewinding cost is 65,000 rupees, then rather than going for rewinding and saving those 35,000, go with the new one. It will have a payback of less than 1.5 years. So it's just said that payback will be less than 2 years for motor which is running for 4,000 hours per year, and energy cost is 6 rupees per unit. So it will be even lesser for 7 or 7.5 rupees electricity cost. Motor rewinding is useful whenever on-shelf motor is not available, like a just similar motor is not available in the market, a very particular motor which you have designed for a particular application. In those applications where directly available motor is not there in the market, go with the rewinding. Then some more guidelines for rewinding. The motor whenever gets rewinding again and again, every time its efficiency drops from the range of 2 to 20%. So when you are having a second or third rewinding, it will have a drastically reduction in the efficiency. So this is a checklist to consider when we rewind the motor. Use proper method of cleaning. Go for at least F class or better insulation. Use a phase insulation between all phase junctions. Use tie and blocking method to ensure mechanical stability. Brace rather than crimping the connection. Use proper lead wires and connection lugs and apply proper varnish treatment whenever we rewind it. Then comes another related topic with the energy saving in motor, that is how to have maintained system operating condition, that is power quality and power factor. These two parameters are also important when we talk of motor. So when we say a power factor, if it is drops below 95, some companies levy the charge. In some utility, it is below 90 also. So in addition to increase electrical billing with the lowering in the power factor, there will be it will have a reduction in a plant voltage. It will have effect on electrical distribution system and system's capacity to deliver electrical energy, that is based on electrical fundamentals. So hence, whenever there is a transmission line, transformer feeders, they are to be used, then we have to select them in such a way that minimum effect is there on the power factor. Use a capacitor on almost all equipment, that will also have a power factor maintained. And use automatic power factor controller, demand controller, because that will also help to maintain the dropped power factor. Motor is designed to operate in a particular power condition. Say, for example, there should be certain parameters like voltage, current, frequency. At that particular condition, motor should operate. And whenever there is a deformation or deterioration, the performance of motor will also affect it. In particular, when the motor is used with a PLC or a soft starter, it is very sensitive to the power quality. So we have to take care of that. More than 10% of imbalance, it will create efficiency reduction, overheating, and bearing failure. So unbalanced line voltage decreases the efficiency of induction motor, and it can have a serious effect like overheating, reduced torque availability, or reduced full load performance and damage or complete motor failure. So it's not advisable that more than 5% voltage imbalance should take place in any motor operating condition. Here, there is an effect of power quality shown. Here, there is an effect of power quality shown that when there is a power change, then there is an effect on a starting torque, as well as there is an effect on a speed, that is shown in this table. Again, whenever there is an imbalance created, temperature increases and heating of motor takes place. So possible reasons for imbalance is there that there can be unevenly distributed load on the same line. So redesign them. There can be incorrect operation of power factor corrector. There can be loose or dirty connections. Transformer tap is there, or a different cable sizing in the same line is used, or there can be a faulty line or faulty circuits are there. Just like power quality, there is a effect of harmonics, which is spikes in the voltage, that is also there on the motor. And 5th and 11th harmonics distorted, they affect the motor performance and they need to be taken care. Use of VFD with the motor is advisable in a particular industries. So that list is shown over here. Wherever different speed applications are there in assembly line, in pneumatics line, there the use of VFD is advisable. Wherever a process is continuously demanding adjustment of flow from pump, fan, etc., their flow rate should keep on varying, then over there the variable frequency drive use is advisable. Then they have advantage of lower energy cost, improved reliability, fewer maintenance, and more effective process control. So in a VFD system, frequency of electrical power is controlled, and that by large controls the speed of the motor. So it is most effective for varying torque and load application, in particular for fan, blower, and pump, also for compressor. So they are reliable, they are flexible, and they will reduce the maintenance of the system. So variable frequency drive applications are, they are used for for fan and pump. They can be used in a material handling, machining and fabrication. And they are more advisable where there is high annual operating hours or a variable load characteristic, and moderate to high rating of the system is there. Over there, use is advisable. If we talk of optimizing the entire motor assembly with the pump or with the any driven system, then always go with the minimum energy performance standard, follow that. Change the connections that can save the energy with the minimum operating cost or a no cost involvement. When we change the connection, then also it can improve the efficiency. Whenever we think of rewinding, go with the more copper. That will also add on the performance. Use for soft starters for motor, that will have easy startup. It will have a lower stress on the lining, and that is advisable. Reduce idle and redundant operation. Many times we have seen that in a lunch break or in other breaks, operators just keep on motor disengaged from the load and keep it running. So that will also consume the power. So monitor those types of applications. And optimize transmission efficiency. Go with the good quality belt rather than standard V belt. Go with the corrugated V belt or a synchronous V belt. So they will have a better efficiency compared to standard V belt. So here there is one case study shown that a motor which operates at a 75% load and consumes 5 lakh units annually. Calculate the increase in efficiency if we shift from V belt to synchronous belt, which is 93% efficient to 98% efficient. So based on annual usage, it is shown that 27,000 units are being saved by just replacing the belt. Hence, replacing the belt is advisable because that is just costing almost nothing. Optimize the complete system. It also means that we have to look at the alignment between pump and the motor, or the end use and the motor, because misalignment will always increase wear and tear. It will make bearing to get worn out, and it will have more power to be consumed. So we should consider that. Always have a regular maintenance. Have 3 types of maintenance: scheduled, prepared and followed. Preparation is always done, but following is many a time missed. So think of it. There should be weekly schedule, monthly schedule and yearly schedule. So weekly schedule will have a basic checks like oil level check, inspection of shaft and starter, etc. Monthly check will be removing dirt and cleaning the certain parts, while yearly maintenance will have regreasing or rechanging the lubricant, etc. So maintenance is always better than unscheduled downtime, and we should take that wisely. And this is the last and most important part of the motor segment, that is use of energy efficient motor. What is energy efficient motor? Compared to standard motor, when we have a motor having better fan, lower friction bearing, thicker conductor and better core material, it will ultimately have losses reduced from 20 to 40%, and it can increase the motor efficiency from 1 to 10%. So this is always good to have energy efficient motor, and it will have a better working condition achieved. Here the reason for losses in energy efficient motor reduction is given, that why energy efficient motor will have a lower losses. Iron losses will be reduced because thinner gauge material is used. I square R losses will reduce because more copper is used. Just like that, our rotor losses are reduced because large conductor bar of copper is used. Friction and windage losses will be reduced because it will have a efficient fan, and stray loss will reduce because it will have a better quality and optimized design. So this will ultimately have 1 to 10% rise in efficiency achieved. And generally, energy efficient motor which are costing 15 to 30% higher than standard motor, but it will have a payback achieved. Why we should adopt energy efficient motor? Because in the present scenario, electrical motors, they are consuming 40 to 50% of total energy produced. Also, the cost of electricity is 120 times of its cost of production. cost of water is just nothing. Cost of electrical energy which is used to run the motor is 120% of the initial cost. So we should always think of running cost or a life cycle cost compared to initial cost. Energy efficient motor should be considered in following cases, that whenever we are having a new installation created, whenever we are purchasing or procuring equipment packages, instead of rewinding failed motor, if we are going with the new one, then go with the energy efficient one. To replace oversized or underload motor, then also we should go with the energy efficient one. And as a part of energy management or a preventive management program, many companies take up this drive that change their equipment to energy efficient one, to take the rebate of the government, to take the subsidy provided, or to, as a part of their energy policies, they make such changes. So in those cases also one should go for it. Here there is a comparison of standard motor versus energy efficient motor. It is interesting to know. A standard motor will have a lower initial cost, but if you compare its operation cost, it will be high. While in case of an energy efficient motor, its initial cost will be high, but its energy cost, that is life cycle cost, maintenance cost, that is less. And this particular triangle that shows saving achieved in its lifespan. And this particular diagram shows that why premium efficiency motors are better. They have a higher slot fill, lower loss, premium steel core, longer stator steel stack, and more copper used in the winding. Because of this, these motors are better. And we have a category from I1 to I4, and they are I1 is standard motor which we normally use, 2 is high efficiency, 3 is premium one, and 4 is super efficiency. So based on different countries, their categorization is given. I1 and I2 for different rating for India is shown over here. There is a complete table. This is just a part of that table. Why people are not adopting energy efficient motor? Some hidden stories are shared over here. The end user should always know that torque and speed requirement. When you go to buy the motor, most of the time these things are only known, and efficiency and power consumptions are not known. Second and most important reason is motors are not sold by end users. They are sold to manufacturer of fan. Say for example, if Crompton is making a fan, then Crompton will buy the motor. You as an individual or me as an individual are not going to buy the motor. So if I want to make my fan to be sold at a lower rate, obviously I'll select a motor which has a lower initial cost. So a manufacturer of fan, motor, pump, or any other equipment who is using the motor will not always go with the high energy efficient motor. This comes into the picture when they have to give B star rating and labeling program to be followed. When they have to put star rating or when they have to meet certain mandates, in that case, they will go with the motor which are super efficient. Otherwise, they will just select based on the criteria or based on the warranty guarantee terms. There exist multiple standards in case of motors, and again, all countries have different standards. So there is no worldwide, both we are streamlined. There is streamlining going on, but still we are facing the problem that there are multiple standards. So a person who is good with one cannot be able to understand the other. There is lack of awareness among the end users for energy efficient motors, and end users demand lower investment cost as just mentioned. So OEMs are not being asked for high efficiency solutions. Some more limitations, like there are different measuring units, like some follow HP, other follow kilowatt. So that is also confusing among the countries and within. Uniform testing methods are also not available. That is also an issue. And motor manufacturers also misuses the jargons like extra efficient, high efficient, super, ultra. Whether they are selling standard motors or energy efficient motors, there is no some standards. they can use any word. So these words are misleading to laymen. Those who are non-technical person, they always believe that when you put a word high, it's good. It's like rating. When you put 5-star, it is better. So something like that, same thing happens in motors too. Here, the fact is shown that when is energy efficient motor is cost effective. When there is extra cost of energy efficient motor is quickly repaid in terms of payback, then it is good. When we are making it operate more than 4,000 hours per year, then it is good. It will have a less than 2 years payback, which is always recommended. There are ready to use softwares available where which suggests that shall we adopt with the energy efficient one or the standard one. They consider hour of operation, percentage load at which they are operating, cost of electricity, what is subsidy available, or what is the salvage cost of old motor. They are considered, and based on that softwares can suggest it. When is energy efficient motor cost effective? That is shown by this example over here. This is the equation which is showing annual energy saving that says that HP, that is rating of the motor multiplied by load at which it is operating, to convert HP to kilowatt, hour of operation, electricity cost of the company, efficiency of standard motor, and then efficiency of energy efficient motor. So for a new motor, the annual saving to be considered over here. So price premium minus rebate divided by annual saving will give us the simple payback in a year for a new installation. Or for a retrofits, we have to consider motor price, installation charge to replace the motor. We have to reduce, deduct rebate available, and salvage, that is the cost of the old motor. And then we have to divide it by the annual saving, and we can come across the value. So there is a good example given that a 3.7 kilowatt 4-pole motor in the frame of given one is having standard efficiency of 85% and energy efficient motor is 88.3%. Cost of standard motor is 7,215 bucks, while the same for energy efficient motor is 9,380 bucks. So calculate simple payback for 4,000 of working hours and at the cost of 5 rupees per unit, as well as we have to assume motor run of 80% of the load. So when we use that previous equation, we can come across the value of annual saving, that is 2600, and extra cost saving is 2165. Hence the payback turns around 10 months of the time. So it's always good to invest around 2000, that is 2165, because we are going to recover in 10 months, and ahead of that what you will be earning, that is a lifetime earning. Apart from saving electricity, when we go with the efficient motor or a super efficient motor, it has a multiple advantage that it has a more reliability, longer manufacturer warranty, less downtime, reduced replacement and maintenance cost. On a large scale, they will have a lesser electricity, hence power plant size will be reduced. So if many person replaces their motor with the efficient one, then the overall power plant capacity requirement, that will reduce fuel burden, that will also reduce. It will reduce power fraction correction requirement, so that cost also be saved, and reduce losses on energy efficient motor and less heat to environment, and thereby reduce power consumption of the light system like HVAC or cooling tower or any, and have a better bearing life, quieter operation, and many. So if I summarize the thumb rules of what I have discussed about motor, then they are like this. Voltage balance of 2.5% will reduce the motor efficiency by 1.5%. Energy efficient motor cost up to 20% more than standard motor, but it will have payback of 1 to 2 years. Rewound motor will reduce efficiency from 2 to 20%. When it is less than 40%, 40 HP, it will be 2%, less than 40 HP, 1%. And if rewind cost is 50 to 65% of new motor, then always go with the replacement. So thank you all. This was all about my talk on energy saving in pump and motor. As I said, I am also on a e-learning platform. I have already developed few courses which are related to energy saving. Right now, they are launched on Udemy. So if you wish to join, you can join them Udemy, or you can contact me if you wish. We can share those courses with you. And if you are preparing for energy audit examination, or if you are looking for any kind of energy audit industry, and if you are looking for any guideline, you can always reach to me. With me, there is a team of few other persons. Those are working on all these types of presentations and industrial audits. So by this, I am ending my presentation over here. And now there is open call to all if you have any question or if you have any suggestions. I don't promise that I'll answer all the question at the same moment, but I'll definitely get back to you if I'm not able to answer any of your questions. Thank you.
Thank you, madam. It was indeed a session filled with knowledge. Now, with your permission, I will like to ask Ratnam madam to start the question answer session. Hello. Yes, ma'am. Can we start with the question answer session? Hello. Hello, Dr. Sonal ma'am.
Yes.
Can we start with the question answer session?
Yeah, sure.
Okay, fine, ma'am. Oh, just a second, ma'am.
Good afternoon, ma'am. We have nearly four questions. First question is by Professor Priyanka Deshmukh. Uh, Thermal expansion, which type of thermal expansion can be used for the
Yes.
pumps? Which type of thermal expansions can be used for the pump?
There are expansion joints available which can be attached to the pump when we are talking of a high applications, like when we are handling a high temperature fluid or all. And in those cases, we can attach those expansions. They are to be attached on a centrifugal pump. They are available.
There is another question by Professor Chetan Rane. Is there any latest technology that can help us while selecting a pump to minimize the losses?
I missed the initial part of the question. Can you repeat? Some connection issues are there.
Okay, yes, ma'am. Second question is by Professor Chetan Rane. He is asking, is there any latest technology that can help us while selecting a pump to minimize the losses?
Okay. Again, there are softwares available. Each and every manufacturers, they suggest their softwares. We can use those softwares. Then that will have a recommendations that which type of pump is more advisable for a particular operating conditions.
Okay, thank you, ma'am. Next question is by Professor Ashwini Gotmare. Are there any softwares or AI programs available to predict the performance of the motor?
Mm, we use Energy Plus, but for prediction, it is not there. It is there for monitoring, and there are some EMS softwares also there which can monitor the performance. If you wish, I can share those details. We recommend in industry different EMS softwares, that is energy management softwares. They are normally used to monitor the performance, and there is a live monitoring as well as if any discrepancy is there, then there are suggestions based on that. So I'll share those details to the participants.
Thank you
Right?
so much, ma'am. So
And
I conclude our
if somebody is
yes.
interested,
Yes, sir. Yes, ma'am, please.
if somebody is interested,
You
we
can
can
continue,
have
ma'am.
a
Yes.
separate call session on EMS also that shows that how to monitor different devices and how to have cloud-based monitoring installed.
Definitely, ma'am. Thank you so much. Now I conclude our question answer session. Now I request Professor Nitin Deshmukh to give vote of thanks. Over to you, Deshmukh sir.
Hello, good afternoon to all. It is my privilege to propose vote of thanks on this occasion. I, Professor Nitin Deshmukh, co-coordinator of Sttp Phase 2, on behalf of MCT's Rajiv Gandhi Institute of Technology, Department of Mechanical Engineering, and on behalf of organizing committee of AICT AQIS sponsored online 1 week short-term training program on recent trends in energy management and audit, and my own behalf extend a very hearty vote of thanks to Dr. Sonal Desai for accepting our invitation as resource person and shared her valuable knowledge with us. She has given good insights on topic energy saving in pump and motors. Under this, you have covered different types of pumps, selection procedures, governing laws, performance curves, flow control and pump losses, energy saving measures and calculations, case studies in energy loss in throttling and trimming of impeller, energy saving potential in pump, energy conservation in motor, appropriate loading of motor, selection of right motor, assessing motor and drive, system operating condition, use an energy efficient motor. So, which are very helpful to all domestic users as well as engineers working in industries. Thank you so much, ma'am. Thank you very much.
Thank you,
Tomorrow,
sir.
25th, thank you, ma'am. 25th November, tomorrow, 25th November morning at 10 a.m., we have fifth session by Mr. Milind Daigaonkar on topic energy conservation possibilities in electrical system. Uh, Now I request you all participants to join that session. Now I request technical team to end the session. Thank you very much for joining. Thank you so much to all.
Thank you, sir.
There is a request. Hello.
Hello, ma'am.
There is a
Yes,
request
ma'am.
from. Hello.
Yes, ma'am.
Please share the feedback on my email. If any particular feedbacks are there, kindly share it. Right? Thank you.
Yes, sure, ma'am. Yes.